Okay, so the top piece here at 3.1, we're talking about increasing and decreasing functions. So a function is increasing if it rises from left to right. Okay, so that's what the top here is saying. It's decreasing if it falls from left to right. So if we're talking about the definition of an increasing function, it says it's increasing on an interval if for any two numbers, x1 and x2 in the interval, where x2 is the larger number, then the y value for the larger piece, so the y value for the x2 is larger than the y value for the x1. Okay, so it's higher up back here than it is here. Make sense? Okay, it's just the opposite for decreasing. So if I have my x1 here and my x2 here, the y value for the second one has to be lower than the y value for the first one if it's decreasing. All right, so that's just the definition of it. It's more technical than it really has to be because if it's increasing, it's going up, decreasing, it's coming down. Okay? Let's look at the relationship now between the graph of f of x and the graph of the derivative f prime of x. So our f of x is this graph, f prime of x is this graph. Does anyone notice a relationship there? It seems like what? It seems like what's decreasing? The derivative. Okay, so the derivative is always decreasing, right? Do you see how that relates at all to the original, or does it relate at all to the original? Does anyone else notice something different about it? So the derivative is always decreasing, but it's hard to say how that relates to here. You can also look at this one here. What does derivative mean? That's another word that I use for it a lot. The slope, right? So let's just think of this as the slope. So if this is the slope, from here to here, the slope should be what? Not negative. Isn't it above the x-axis? So if the derivative is above the x-axis, that means the slope should be what? If it's above the x-axis, is it positive or negative? Positive, right? So from here to here, isn't the derivative positive? And look from here to here. What do you notice about the slope? It's positive, which means it's doing what? Increasing or decreasing? Increasing. So when the first derivative is positive, the graph is increasing. Does everyone see that? Okay, so let's write that here. The first derivative is greater than 0, or positive if you need to write positive. F of x is increasing. We're going to check if that's the case for the second one over there. So let's look at the first derivative here. Where is the derivative positive? When it's above the x-axis, right? So from here to here, isn't it positive? Is the function increasing from here to here? Yeah, from here to here it increases, right? Also, it's also positive from here to here, right? Is the function increasing from here to here? Yeah, it goes like this. When is it decreasing? Okay, so from here to here, and what do you notice about the derivative from here to here? Negative. So when the derivative is below the x-axis, the function is decreasing. So let's write that down. When the derivative is less than 0, so below the x-axis, our f of x is decreasing. What about when it equals 0? Because that's the only other case here. If the derivative equals 0, let's try about the function. So go ahead and look at the graphs. So the derivative equals 0 here on this graph, here on this graph, and here on this graph. What do you notice about the original function at those spots? wouldn't the slope be 0? Because it's the derivative is 0. Do you see how the slope is 0 here and here, which correlates with those x values, and here? So when the derivative equals 0, f of x has a horizontal tangent, we could say. Any questions on that piece? That works for both the graphs, yep. All of those things worked for both graphs. And all of these things are actually going to work no matter what the graph is. Okay, these are just two examples, but let's think about this for a second. First derivative is your slope, right? So if the slope is positive, that means that the graph has to be going up, right, if the slope is positive? So that's what this is saying. The slope is positive, the graph has to go up. If the slope is negative, think about a negative slope. Wouldn't that go down? And if the slope equals 0, then the slope should be 0, right? The horizontal tangent should occur there. So let's go to the next page. The next page here is just notes. So if you notice, this is the test for increasing and decreasing functions. You probably want to highlight this. It's a huge, huge, huge test in calculus. So if f is differentiable on the interval, if the first derivative is greater than 0, then f is increasing. If the first derivative is less than 0, it's decreasing. And if it equals 0, then it's constant. Okay. Basically what we just wrote. Yep. Any questions on that? So if you look at this here, the first derivative would be less than 0 from negative infinity to a here, which means the function is decreasing. If the function went straight across, the first derivative would be equal to 0, and it would be constant from a to b. And then if the first derivative is greater than 0 like this, the slope is greater than 0, it's increasing. And that would be from b to infinity is how we would write those intervals. Okay. Down here. Okay, there are points on the graph where the function changes from increasing to decreasing or vice versa. So here it goes from decreasing to increasing. Here it goes from increasing to decreasing. And here it switches from increasing to decreasing. It's like there's an asymptote there. Okay. So at each of these points, the derivative is either 0 or undefined. Okay. Here is the derivative 0 or undefined. 0, right, which it says right here. Here, would the derivative be 0 or undefined? Undefined, because there's actually an asymptote there. And if there's a corner in the graph like this, the derivative's undefined there also. Okay? So these are like what we call critical numbers of f, which again is a big word that gets used a lot in calculus, critical numbers. So definition of a critical number. If f is defined, then c is a critical number if the derivative equals 0 or is undefined. So we take the derivative, we set it equal to 0, or we find where it's undefined. That gives me my critical numbers. And we're going to use those a lot on the next couple slides here. All right, so let's go ahead and jump into an example here. And if you have questions on what I'm doing in the examples, make sure you ask, because this is pretty much what you're doing for your entire homework here. All right, so make sure I would write out all these little things that I'm going to be writing so you can follow what you're doing here when you're doing your homework. It says find the open intervals on which the function is increasing or decreasing. So if we want to find where it's increasing or decreasing, when is it increasing? When the first derivative is what? When it's greater than 0. And it's decreasing when the first derivative is less than 0. So you might just want those little notes on there for yourself. So in order to find that, what do I need to do? I need to take the derivative, right? So go ahead and take the derivative. I'm just going to label this as step 1 here. Finding the derivative. Kelsey, what's the derivative of that? Yeah. we go. Everyone else agree with that? Okay, now the second thing I'm going to do is find the critical numbers here. So how do I find the critical numbers? What did it say critical numbers were? 0 or undefined, right, where the derivative is. So is this ever going to be undefined? No, but I can set it equal to 0, right? So find critical numbers, we're going to set this equal to 0. So I'm going to say the first derivative equals 0 when 3x squared minus 12 equals 0. How do I solve that? Add 12, so I would have 3x squared equals 12, then divide by 3, and I get x squared is 4. And then what do I do? Take square root, and what do I get? X is plus or minus 2. You need both, otherwise your answers are not going to be right here. So be careful when you take the square root, make sure you do plus or minus. Okay, now the third step we don't need in this one, but we want to find where the derivative is undefined. So I'm just going to write it here so you have it in your notes. So find when the first derivative is undefined. That's the derivative there. So here we can skip that step. Okay, now steps like 4, 5, and 6 all kind of go together. Okay, so 4, I say set up intervals using the critical numbers. And undefined points. So what I do for this, and it just depends on, your teacher, I guess, here, but I just set up a number line. And on my number line, I put my critical numbers and my undefined points. So what 2 points do I need to put on my number line? -2 and 2. If it would be undefined if I had this over x, or there's something in the denominator, I would set the denominator to 0. So I would say it'd be undefined at 0 if this was the case. Do you see that? Okay. Now with this one, there's no denominator, so you don't have to worry about it. Okay, so we set up intervals. So these are my intervals, -∞ to -2, then -2 to 2, and 2 to infinity would be my intervals here. Now step 5 is finding the derivative, whether it's positive or negative. So step 5 is putting my derivative right here. And I'm going to find if it's positive or negative in each of these intervals. So let's start between -2 and 2. What's a good value between -2 and 2? 0. If I plug 0 into the derivative, what do I get? Positive or negative? Negative. So I put a negative here. Or you can write negative if you want to. How about if I plug in -3 or -4 or -5, any of those values? It would become positive, right, because it's squared here. So if I plug -3 in, I get 9 times 3 is 27 minus 12 is positive. It doesn't matter what the value is, just whether it's positive or negative here. So any number you plug in over here should give you the same positive or negative. What if I plug in +3? Positive also, right? Nope, we don't include -2 and 2, because at -2 and 2, it's 0, isn't it? So that's where it would have my horizontal tangents, okay? So step 6 now is stating whether the function is increasing or decreasing. So if the derivative is positive, what does that mean about my function? It's increasing, right? If the derivative is greater than 0, I know the function is increasing. So f of x, I'm going to say is increasing here. What's it doing from -2 to 2? Decreasing. And what about 2 to infinity? Increasing. So any questions on that? And then you just have to go ahead and actually write it out for your answer. So find the open intervals where it's increasing or decreasing. So I say increasing. So it's increasing from what? Negative infinity to negative 2, and then where else? 2 to infinity. So that would be where it's increasing. And where is it decreasing? Negative 2 to 2. Good. And you don't include anything with those, okay? Because at those spots it's actually 0, which means it's not increasing or decreasing. Yeah, you're not going to be including your endpoints for these. So any questions on that? So you're always doing these steps here, okay? All right, let's try another one then. Find the open intervals on which this function is increasing or decreasing. So first thing I have to do every time is what? Find the derivative. So let's go ahead and do that. Who's got the derivative for this one? So I bring the 2/3 down, and then it's x to the what power? Negative 1/3. So I can move this to the denominator, which I think is what you were doing, right? So 2 over 3 cubed root of x you could write, or x to the 1/3, whichever way you want is fine. Now, is this ever going to equal 0? When does a fraction equal 0? When the numerator is 0. This is never going to equal 0, right? So for step 2, finding where the derivative is 0, that's not going to happen, right? Step 3 is finding where the derivative is undefined. Where would this be undefined? When the denominator is 0, right? So it's undefined. I'm just going to write it out so you have it in your notes here. When 3x to the 1/3 equals 0, which is when x equals 0, right? And if you needed to do that mathematically, you would divide the 3, which would give you x to the 1/3 is 0. And then how do I get rid of the 1/3 power? You cube it, right? If I cube this, I also get 0. So there might be ones where it's not 0, is why I'm showing you that. So we got where it's undefined. The next spot is set up the intervals using the critical numbers and undefined points. So I don't have any critical numbers, just undefined points. And it's only at 0, so that's the only spot I have to worry about. What do I put up here? F prime, good. And then down here I write f of x. You need to write those things on there every time. So if I plug in a negative value, what's true about the derivative? It's negative, right? If I have the cubed root of a negative, it's going to be negative times a negative times a negative. So it's going to end up being negative here. How about if I plug in a positive? Positive. So what's true about the function on the left side here? Decreasing, and here it would be increasing. So then we just go ahead and we write where it's increasing and decreasing. So increasing from what? 0 to infinity. And decreasing from negative infinity to 0. Good. Any questions? So isn't this last one going to be really similar to those? Okay. Go ahead and try the last one. It just involves a little bit extra stuff, so I'll give you guys a few minutes to try that. So if we start this one, we're going to start with taking the derivative, which most of us had, but if you had some trouble with that, then it gives you trouble with the whole thing. So I'm going to use the quotient rule. Low d high is going to be this x squared minus 4. D high is 2x. minus high d low. The high is x squared, d low is 2x again. And then over the bottom squared. And I'm not even going to clean that up at all. I'm just going to leave the denominator the way it is. Distribute your 2x through, and I get 2x cubed minus 8x. And then back here I have minus 2x cubed. Does that look right? So my numerator, these cancel, and I just end up with negative 8x over x squared minus 4 squared. So any questions on that? Okay, so take your derivative as the first step. Second step is finding when the numerator is 0. So I let negative 8x equals 0. When is this true? When x is 0, right? Divide by negative 8 on both sides. So this is my critical number here. And then to find where it's undefined, what do? I set the denominator to 0. Good. Now to solve this, some people tried to multiply this out, and that gets kind of messy. What I would do is square root both sides, because if I square root this side, I get x squared minus 4, and square root the right side, I just get 0. Then I can add my 4 over and take square root, and what do I get? Plus or minus 2. So these are my undefined points. So these are the 3 points that really set up my intervals, right? So you need to have those correct, obviously. And then I go ahead and I set up my number line. I've got 0, negative 2, and positive 2. What do I write up at the top? F prime of x, and at the bottom, f of x. So it should always look like this. Now f prime of x means I'm plugging in my derivative. What do you notice about the denominator? It's squared, so it's always positive. So really what determines whether it's positive or negative is the numerator. So if I plug in something to the left of negative 2, is it going to be positive or negative? Positive, because it's a negative times a negative. How about like negative 1? Positive. How about 1? Negative and negative. So that means it's increasing here, it's increasing here, it's decreasing here, and it's decreasing here. Okay, now this is where some people just might write their answer wrong, even though they did all their work right. So at negative 2 and 2, what happens? It's undefined. So is it increasing from negative infinity to 0? No, because at negative 2, it's undefined. At that spot, it's not increasing. Okay? It's actually probably, it's a vertical asymptote there, right? It can't increase when there's a vertical asymptote there. So what we're going to say is it's increasing from negative infinity to where? Negative 2, and then where else? Negative 2 to 0. And it's decreasing from 0 to 2 and 2 to infinity. Some questions on that? Now I'm going to try putting this original equation in my calculator and just seeing if this makes sense, because that's how you could check your answers here. Okay, so we throw this into our y equals window. Usually I start with just negative 10 to 10. Obviously we want to be further than the negative 2 to 2 so we can see what's going on here. And I'll try that for my x's and y's. We'll see if we can see the whole thing here. Okay, so looking at this graph here, we just want to make sure our answers make sense. So again, this is the original. This tells us something about the original, right? So is it increasing from negative infinity to negative 2? Yeah. Is it increasing from negative 2 to 0? Yeah. Does everyone see that? So do you see how it can increase, and at negative 2 it's got an asymptote there? And then it's decreasing from 0 to 2, that looks right, and it's decreasing from 2 to infinity. All right, so this supports what I had there. Any questions on that? So you can always compare it to your graph, make sure the graph actually, or the answers actually make sense for the graph that you started with, okay? And there's your homework. Oops.